All right, let me go ahead and do a think out loud for the first three. Maybe I'll do these three. This one is in factored form. It's in factored form because I see two sets of parentheses. I can write the form above it. I notice that my A value is negative. If it's negative class, that means it opens down. Does that match my graph? Yes, it does. The other clue that I have is that my R values, so again, I'm going to have to switch these, x minus minus 1, x minus minus 4. I did that because I want to have an R value that's negative 1 and an R value that's negative 4. The R values are on the negative sides of the x-axis. So R is negative 1, R is negative 4. That's on this side. So if you need to, you can draw a graph for each one of these. So negative 4, negative 1, opens down. Does that match our graph? Yes, it does. So this one does match. Let's try the second one. This equation here is in standard form. In standard form, I have ax squared plus bx minus c. Sorry, plus c. My a value is negative. If my a value is negative, that means it's going to open down. So that matches. Now, the other part of standard form is the y-intercept. I have a y-intercept of negative 6. If negative 6 is somewhere down here, then the graph could eventually go through that point. So with that y-intercept of negative 6, that does match my graph. I'm going to circle this one as well. And let's find one with vertex form. Let's do this one down here. If I write vertex form below it, f of x equals a times x minus h squared plus k. My a value is a negative, so my graph's going to open down. That matches my graph. And then the other part is my h and my k. My hk is 6 and 3. It's saying that my graph should be something like over here, 6, 3. Does that match our graph? No, because my vertex here is in quadrant 1, and this vertex is in quadrant 2. So this equation doesn't match. Okay?